Linear functions, also known as first degree functions. We're going to be looking at the equations of a line in standard form and in general form. We'll also look at parallel lines and perpendicular lines. For standard form, that's y form. Y equals ax plus b, where a is the slope, which is the rise divided by the run, and b is the initial value, or the y-intercept. You can get this from the graph, or you can work it out algebraically. Let's see what happens when we change the slope. I'm going to write y is equal to, and then see, as we change the slope, it just changes the angle, the slope. If we change the b, look what happens. The b lifts it up and down. The slope changes the angle, and the b changes the up and down. I know it looks like it's going left to right, but it's passing me through 9. So then here the b is 7, and then down to 2, the b is 2. The b lifts it up and down, and the slope just changes the angle. Let's look at an example. We have a table of values. We can figure out the equation from the table of values. The slope, the a, is delta y over delta x, which is y2 take away y1 over x2 take away x1. Pick a pair of points. I'm going to do 0 and 4 is my point 1. My point 2 is 3 and 16. The delta y would be 16 take away 4, the y2 take away y1, divided by the x2, the 3, take away the 0, which is 12 divided by 3, which is 4. The slope is 4. Then we have y is equal to 4x plus b. To get the b is the initial value. It's the y-intercept, or the value of the y when the x is equal to 0. And we can just read this off of the chart here. Sometimes you won't be given the initial value or the y-intercept. You might have to calculate it. So when you have to calculate it, this is how you would do it. Pretend we didn't know that the b was 4. We could use one of these points. Doesn't matter which one you use. I'm going to use 3 and 16. I'm going to replace the x with 3 and the y with 16. That gives us 16 is equal to 4 times 3 plus b. So that's 12 plus b. And then I'm going to subtract 12 from both sides. And that's going to give me 4 is equal to b, or b is equal to 4, just like I have here. The equation becomes y is equal to 4x, that's the slope, the a is 4, and the b happens to be 4 as well. Here we have a line. Step 1, find the 2 points. I'm going to call this point right here, point 1, and this point, point 2. Then you want to find the run. The run is always positive. It's easier to think of it that way. This is the run from point 1 to point 2. It is the horizontal distance between your 2 points. The run is 4. And then we're going to find the rise. The rise is either up or down. If it's up, it's a positive value. If it's down, it's a negative value. This is always vertical. This is the rise. Rise in this case is 2. The slope, we're going to calculate step 4. Calculate the slope. The slope is the rise divided by the run, or the delta y over delta x. In this case, the rise is 2, the run is 4, so 2 divided by 4, I can reduce that to 1/2. Step 5, find the b. Find the initial value. The b is the y-intercept. It's also called the initial value, and we can read off the graph right here. The b is 2. Our equation becomes y is equal to ax plus b. The a is 1/2, and the b is 2. Y equals 1/2 x plus 2. A standard form versus general form. A standard form is y is equal to ax plus b. The general form is ax plus by plus c. Now, this b is not the same as that b. This a is not the same as that a. This is an equation, y is equal to negative 1/4 x plus 3. This is the same equation in general form. The a would be 1, the b would be 4, and the c would be negative 12. Let's look at the x-intercepts. The x-intercept is the value where it crosses the x-axis. When y is equal to 0, what's the x value? I'm going to take my standard form, and I'm going to set y is equal to 0. Then I'm going to solve for x. So I'm going to subtract b from both sides. That's going to give me negative b is equal to ax. Then to get the x alone, the a is multiplying it, so I'm going to divide both sides by a. And that gives me x is negative b over a. The x-intercept for the standard form is negative b over a. For the general form, I'm going to do the same thing. I'm going to take the general form, and I'm going to make the y equal to 0. I'm going to get b times 0 plus c is equal to 0. And that's just going to disappear. So we're left with ax plus c is equal to 0. To get the x alone, I'm going to get rid of the c first. I'm subtracting c from both sides. We get ax is equal to negative c. Then, to get the x alone, the a is multiplying it. I divide both sides by a. That gives me x is equal to negative c over a. So this is the x-intercept for the general form, is negative c over a. For the y-intercepts, this is when x is equal to 0. The y-intercept for the standard form is b. Let's prove it. We're going to make x equal to 0, and that's just going to give us y is equal to 0 0 plus b, which is just y is equal to b. The y-intercept is b. For the general form, I'm going to set the x is equal to 0, and that's going to give us a times 0, which is 0 plus by plus c. So we're going to be left with by plus c. I want to get rid of the c, so the y is all alone. Subtracting c from both sides, we end up getting by is equal to negative c. The b is multiplying the y. I want to get rid of the b, so I'm going to divide both sides by b. That gives me y is equal to negative c over b. And that's the y-intercept for the general form, negative c over b. Let's convert from general form to standard form. If you have a question like this, you have negative 9x plus 11y minus 99 is equal to 0. That's general form, and they want it in standard form. All you have to do is solve for y. I want to get the 11y's all alone. I want to get rid of this negative 9x, so I'm going to do the opposite. I'm going to add 9x to both sides. We want to eventually graph this. So here's a graph. I'm adding 9x to this side, adding 9x to that side. That's going to give me 11y minus 99 is equal to 9x. I want to get the 11y's all alone. I want to get rid of the negative 99. I'm going to add 99 to both sides. That's going to give me 11y is equal to 9x plus 99. I want to get rid of the 11. That's multiplying the y. So I'm going to divide both sides, which means divide all terms by 11. 11 divided by 11 is 1, so we end up getting 1y. 9 divided by 11 doesn't go in evenly, so we have 9/11ths x. And then 99 divided by 11 is 9. We end up with y is equal to 9/11ths x plus 9. The b value is the 9. I'm going to go over the 9, plot my a point. The slope is 9/11, so I'm going to delta x, move over 11 steps, that's right here, then delta y, move up 9. I'm at 9, up 9 brings me up to 18. Here, that's my b point, and then you make your line. Let's say we have two lines. We have line AB is negative 2/5 x plus 10. Let's graph that. We have negative 2/5 x plus 10. 10 is the b value. The slope is negative 2/5, so delta x first is 5. Delta y is negative 2, like that. If I want to copy that line and move it around, so notice these are all parallel. Notice what parallel lines have in common. They have the same slope. If I was to plot it here, where it's crossing at the 8, we end up getting two parallel lines. We end up getting negative 2/5 x plus 8. Notice they have exactly the same slope. Negative 2/5, negative 2/5. Parallel lines always have the same slope. Let's look at perpendicular lines. We're going to graph the same first line. I want to make this line perpendicular to that line. So here, I'm just going to move this down here. And then let's see what happens when it becomes perpendicular. That's 90 degrees to each other. And notice this one has a slope as I'm moving over 5, down 2. Here I'm moving over 2, up 5. Still have that 2-5 relationship, it's just they're inverted. Instead of over 5, down 2, I'm going to go over 2 and up 5. Line AB is y is equal to negative 2/5 x plus 10. Line C, the b value is 5. The slope, the delta x is 2, and the delta y is positive 5. It's y is equal to positive 5 over 2x plus our b value 5. The b value can be the same. We can make that 10. It's still going to be perpendicular. The b doesn't really matter. Let's have a look at that. If we lifted this up to here, it's still perpendicular. The b doesn't come into it. Notice the slopes. This has a slope of negative 2 over 5. This has a slope of positive 5 over 2. When you have perpendicular lines, the slopes are negative reciprocals of each other. There's a sign change and they've flipped. Let's look at a couple of examples of parallel and perpendicular lines in action. Find the equation of a line that's parallel to y is equal to negative 3x minus 18 and passing through the point negative 945. If we graph that, y is equal to negative 3x minus 18, so it's passing through minus 18. The slope is negative 3, so that's negative 3 over 1. Move over 1 and down 3. 1, 2, 3. We want it to be, the new line to be parallel to this line, so I'm just going to hold down the option key and drag a new one. Wherever I drop this, this is going to be parallel. And I just want to make sure that it's passing through negative 945. Put the C point on negative 9. Like that. And drag it up to 20. And we want it to go through 45. There's 41, and there's my 45, like that. But it's going through that point, and we just have to find the b value, and the b value is at 18. We end up getting y is equal to negative 3x plus 18. We could also do that algebraically. We could have said, find the equation of a line that's parallel to y is equal to negative 3x minus 18 and passing through the point negative 9, 45. We know it's going to have the same slope because it's parallel. We can say y is equal to negative 3x plus b, and then I could use the point negative 9 and 45 to find the b. I replace the x with negative 9 and the y with 45. We have 45 is equal to negative 3 times negative 9, which is positive 27 plus b. Then I'm going to subtract 27 from both sides to get the b alone. That gives me 18 is equal to b. We end up with the equation y is equal to negative 3x plus 18. We press answer to see if we're right. Let us look at a perpendicular line question. Find the equation of a line that is perpendicular to y is equal to negative 4x plus 5 and passing through the point negative 4, 20. We can do this graphically, and we can do it algebraically. Let's do it graphically first. I'm going to graph y is equal to negative 4x plus 5. The b is 5. Slope is negative 4, which means negative 4 over 1. I'm moving over 1 and then down 4. 1, 2, 3, 4. A line that is perpendicular to that is going to have, the slope is going to be the negative reciprocal of negative 4. Instead of being negative 4 over 1, it's going to flip and it's going to change sign. It's going to become positive 1 over 4. The delta x is 4 and the delta y is 1. Notice these lines are perpendicular. Now all we have to do is make sure it goes through the point negative 420. Here's negative 420 is right about there. So we're just going to drag the whole thing so the C point goes through negative 420 like that. Notice our b is 21. We get this nice equation. Y is equal to 1/4 x plus 21. We can do it algebraically as well. We know that the slope of the first line is negative 4. The slope of a line that's perpendicular to this is going to have the negative reciprocal. The negative reciprocal of negative 4 is positive 1/4. We have y is equal to 1/4 x plus b. And then to find b, I'm just going to replace my x with negative 4 and the y with 20. We have 20 is equal to 1/4 times the x value, negative 4, plus b. All right, 1/4 of negative 4 is negative 1, where the 4's cancel, and you're left with 1 times negative 1. We end up getting 20 is equal to negative 1 plus b. Add 1 to both sides. B is 21. We get the equation y is equal to 1/4 x plus 21. Let's go and see if that's right. Y is equal to 1/4 x plus 21, and then I press answer. That's it for lines. Have a good day.